All right, welcome everyone to Setting the Foundation, Lesson 1 in Electrical Systems. And today we're going to be talking about electricity. We're going to get into the very basics of just what it is that you understand moving forward when you start talking about components and sensors and stuff like that, what I'm referring to, and when we get into troubleshooting. So when we're talking about electricity, we have three different categories of it. And that's going to be voltage, current, and resistance. This is what makes up electricity. For the analogy, we're going to be going over a water pipe. When it comes to voltage, voltage is measured in V or volts. When it comes to current, the number is, sign is I, and it's going to be measured in amps. When it comes to resistance, this is an R, and this is measured in ohms. When it comes to voltage, this is going to be the main pushing force. Whatever is driving the electricity, the push, the force of that electricity, the pressure, if you will, is going to be the voltage. So if we want to run our analogy, we're going to say that this is the push or pressure. So this is like if you have a 24-volt system, you have 120 volts, 480 volts, we're talking about the amount of pushing electricity. When it comes to current or amps, this is actually going to be the flow. This is what's actually going to be consumed. So this is the flow or the water, and this is what's actually being consumed. So if you are going to be running, let's say, a small device or a sensor, you don't need that much current, so therefore you don't need that much flow. Now, if you were to run something larger like a motor, you're going to need a lot more current, you need a lot more flow. So that's like the amount of water inside a pipe, right? The water you're going to be using. We have a little bit of water, a little bit of flow. Doesn't matter how much pressure you have. If you don't have that much flow, you're not going to be able to do that much, right? Now, typically, if you have, we're going to say, you increase voltage, this will increase current if the resistance is the same. I know my handwriting is a little difficult here. So now we're going to talk about resistance, right? So what is resistance? So think of resistance as like a very narrow pipe or a kink in a hose, right? The actual tubing around it. So you could have all this pressure and you could have all this flow, but if you have a kink in your line, you're not going to get anything out of it, right? And that's typically what you have whenever you have a disconnect in a circuit. If you have something and you have a break or an open or anything like that, all of a sudden you have very high resistance, then you're not going to be able to have any current flow. So if you have high resistance, this is going to equal low current. And that's what I said, it depends. So you could increase voltage. However, if you still have high resistance or you still have a thin pipe, you're not going to be increasing current. If you got that kink in that hose, you could increase the force, the pressure all you want. Your current's not going to increase because of the fact that you have high resistance. So when it comes down to it, when it comes to measuring this, we're going to be using what's called Ohm's law. And Ohm's law is our formula of voltage equals current times resistance. So anytime we need to figure out in a circuit what we're going to be dealing with when it comes to the full electricity of it, we're going to be utilizing Ohm's law right here in order to find out. So if we know our voltage and our current, we would plug that in, and now we know what our resistance is. If we know what our resistance and our current is, then we can find out what our voltage is. So this tells us everything we need to know about that circuit. Very important to understand the basics of this. So again, it's very simple when you think about it in that way. If you have a large system like conveyance or anything like that, you're going to be running higher voltage, you're going to be needing higher current, which means you're going to be needing low resistance. And so that's what you're going to be utilizing here. Now that we got this out of the way, we're going to be talking a little bit more about voltage. Specifically, we're going to be talking about what's called AC and DC. Let me erase this right here. So there's two different kinds of voltage, and that is alternating current and then direct current. So when it comes to alternating current, this is basically where the flow is going back and forth. The flow of current is going back and forth. Whereas direct current is just one flow, one direction. Now, what are the pros and cons? Well, basically, when it comes to alternating current or AC, it's going to be a lot easier to step up the voltage in order to run that for a longer distance. When it comes to direct current, that's going to be more utilized for smaller, sensitive electronics where you don't want any of that. And the reason why is because when it comes to alternating current, we actually have what's called single phase and three phase. And I'm sure you've heard this before. So when it comes to direct current, there is no phases. Let me give you an example, okay? We're going to do a picture right here. Let's say this is our voltage traveling, okay? When it comes to direct current, this is how it's going to be. It is a pure signal that is going through, and there is no jumps there. There's no nothing to it. It's just exactly where it needs to be. Perfect. There's not going to be any eruptions or anything like that. When it comes to alternating current, we draw in the same box right here. Let's say that this is our middle mark right here, just to give you a reference point, right? This is where we want it to be, right? When it comes to single phase, you're going to be having one phase, and we're actually going to do this in a different color. I'll give you a good example here. And it's going to be kind of like this. Okay, so you have one phase. Now, typically, because there's going to be some intermittent stuff like that in there, you're not going to be getting a pure constant signal. It's going to be a little bit bumpy because it's going back and forth. So that's why this is typically utilized for smaller appliances or lights. When it comes to three phase, right, it's referring to three sine waves. So when it comes to single phase, that's one wave. You have one wave right here. When it comes to three phase, it's actually three waves at 120 degrees separation. And what that does is help fill in the actual gapping whenever the wave starts to drop. So for our second phase, forgive me a little bit here, probably going about here, not the best artist when it comes to this. So let's just say it's kind of like that, right? And then our third phase, grab the green here. I'm going to say it's kind of like boom, 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 and then I kind of forgot to include it in there. Not that good of a drawing, but basically the overall concept here is you see how it's filling it in, right? If we just had one wave, you have this gap, this gap, this gap. Whereas the three waves, because they're 120 degrees apart, you don't have as many gaps whatsoever. You get a much better constant signal. And that's why you're going to be utilizing this for heavier loads. Three phase is commonly found in either 230 volts, 480 volts, 600 volts, your larger systems. And this also enables you to get a much stronger current. This is why you're going to be utilizing AC when it comes to your heavy machinery. And again, DC is one direct smooth current. This is typically going to be a lot lower voltage though. When you're dealing with DC, you're going to be dealing with 5 volts, 12 volts, 24 volts, at most 48 volts DC that I've seen. When it comes to AC, we're dealing with, again, 110, 208, 230, 480. So it just kind of depends if it's single phase or three phase or not. So now that we understand electricity, now we can start getting into the specific systems we're going to be talking about. Because when it comes down to understanding what's going to be powering a sensor, what's going to be powering a motor, what's in our control panels, it's very important to understand this for when we're troubleshooting, if we're trying to figure out where our problem is if something is not working. So I hope this makes sense right here. And I'm going to be seeing you all in the next video. We're specifically going to be talking about devices, inputs, outputs. See you then.